Hello everyone, and in this video we are going to be discussing uncertainty and superposition. And the goal of this topic will be to help us better understand the behavior of an electron once we get down to the quantum level. And the quantum level is talking about things when you're looking at a single electron or a single atom or even a small group of atoms. And so to begin, let's say that we have an electron and that there are two properties that this electron can have. It has some kind of hardness and it has some kind of color. And in terms of hardness, it can either be a hard electron or a soft electron. And in terms of color, it can either be a white or a black electron. And so that's our starting point. And so what we can do is we can devise a box of some kind, a measuring device, determine if I was to take an electron and put it into a box, and inside of this box I was measuring the hardness, and outside the right of this box would be soft electrons, and exiting the top of this box would be hard electrons. That's what we can do. And so all the data that we have experimentally from looking at electrons tells us that if we were to figure out the ratio of hard to soft electrons when we look at a random sample of electrons in our universe, is that the ratio is 50-50, hard to soft. And when I say 50-50, the way I think about it is it basically means we don't know. If I was to give you a random electron and ask you to tell me what its hardness was just by guessing, you wouldn't know. We have no idea. There's nothing to tell us, oh, well, there's a better chance that it could be hard or soft. It's an equal distribution of both hard and soft, so we don't know. Same thing goes for color. So if I was to take another random electron, chuck it into a color box or a color measuring device like a human eye, and you were to tell me whether or not the electron was black or white, and we again wanted to see what was the ratio of black to white electrons in the universe, what we're going to find after we've done infinitely many experiments is that the ratio of black to white electrons again is going to be 50-50. Which is another way of saying we don't know. A random electron can basically have either black or white color, and we don't know. And so the fun things begin when people begin to take these output streams and link them to other streams. So a question that we can have is, well, okay, if I know an electron is black and then I measure its hardness, can I then check and know whether or not it's both black and hard? So what that kind of experimental apparatus would look like is we would take an electron, we would put it into our color box. We know that black electrons would exit the top of this color box, and then we would have a stream of white electrons exiting the side of it. And then if I was to take this stream of white electrons and then put this into another box where I wanted to measure the hardness of these white electrons, and I know coming out of the top of this box are going to be the hard electrons, and exiting the side of this box are going to be the soft electrons. What does our intuition tell us? If I was to then take this stream of soft electrons and then put it into a box to measure the color, my question is, what is the ratio at this box? And I'll try to use an interesting color. What is the ratio of white electrons here? And so what our intuition tells us is that because upstream of our hardness checking box, we were only taking the white electrons, our intuition says that at this stream right here, we would expect 100% white electrons and 0% black electrons. And so what we've learned from our experiments, however, when we look at single electrons traveling through this apparatus, is that this intuition is 100% wrong. This intuition is wrong because what we're actually seeing is that ratio 50-50 again, of 50% white to 50% black. Even though upstream of this box, we had just filtered out all of the black electrons. So it doesn't make any sense to us why there's now this uncertainty in the electron's color when we had just observed it previously. And the reason that we're seeing this uncertainty again in the electron's color is because we had just filtered out all the hard electrons. So now the only thing going into this color box on the far right here are going to be 100% soft electrons. And if we have 100% certainty that the electrons inside of this color box on the far right are soft, then when I try to figure out what their color is, because I know what their hardness is, I don't know what the color is anymore. And so this is uncertainty. And so the uncertainty principle is telling us that basically we cannot know simultaneously the hardness and the color of an electron. We can only know one of them with certainty, and by doing so, we have to let the other property exist in a superposition. And to better understand superposition, we have this diagram here that I will show you. So if we were to take a stream of these white electrons, so I know this is 100% white electrons, and inside of this I will have a hardness checker, and I know that inside of my hardness checker I'll have the soft electrons leaving to the right, and I'll label these streams like a chemical engineer should, and then leaving the top of this box I'm going to have the hard stream of electrons, and then I'm going to have a mirror on either side here that will reflect without changing the property of these electrons or photons or whatever particle you would like. And we're going to have some kind of reverse splitter. And then, so basically what I'm going to say is we still know that the electrons, after they've been reflected on that mirror, are both hard and soft. If we then take this output and plug this into a color checker, and were to then determine whether or not the electrons were black or white in terms of color, and I'm going to draw a diagram under this new box. The question is, what is the ratio of white to black electrons in the top right here? Ratio of white to black is question mark. And the answer is that 100% of the electrons are white. And the question is, why in this case do we know that 100% of the electrons are white, whereas in the case just above we saw that 50-50 split? And the reason is that inside of this new box we were taking both outputs of the hardness checking box, the hard and soft streams of these electrons, even if it's one electron at a time, and then merging them together. And then because we allowed the electron inside of our new box to exist in a superposition of both hard and soft, we could then say with certainty that all of the electrons here are white, because we knew that 100% of the electrons entering our new box were white. And so if we wanted to get sneaky and clever, what we could do is we could then say, okay, well, inside of my new box, what happens if I put a wall here as an electron is traveling along this hard path? If I put a wall here, so this electron that would have been traveling along this hard path right here no longer even knows that it can't take, my new box will not let soft electrons leave because I have this wall here that will absorb all hard electrons, or I'm sorry, this wall absorbs all soft electrons. And if I was to put this wall here while this other electron right here was traveling along this hard path, the question is, okay, now in this case, can I say that because I know this electron is hard, do I now know that it is going to be white as well? And the answer is no, because you've just collapsed the wave function, which is a topic that we'll get to in later discussions. But basically, the issue is that inside of this new box, as soon as you put this little door here that was to absorb all the soft electrons such that no soft electrons can exit your new box, therefore the only electrons that can leave your new box would be hard, you now know with 100% certainty the hardness of those electrons, which means that you have just given up your ability to know the color of those electrons as well because of the uncertainty principle. And so that is the issue that we run into. And so what we have to say is that inside of the box, so just to clarify this, when we filter out all the soft electrons, we now no longer know the color of the electron. So that is the key takeaway from what we see experimentally in quantum mechanics. So the issue is that when we do that, we no longer know it. And so what we have to say is that inside of the new box, the electron is in a superposition of hard and soft. And we have to let it be that way, because if we were to observe it, or if we were to filter out one of the streams, we would then be collapsing our wave function so that we would no longer even know the color. So we just gave that part up. So I'm going to wrap things up with that. I hope this video is able to clarify, or at least introduce, the topics of uncertainty and superposition. And this is not science fiction stuff. This is stuff that we see experimentally through the data, through our observations of looking at individual electrons at the quantum level. And so the reason that we need quantum mechanics is because we need math to help us understand the behavior of electrons when we are inside of these types of apparatuses. And so I'm going to wrap things up with that. Thank you all for watching. Let me know if you have any questions, and take care.